Hello, everyone. First of all, I would like to thank Mr. Michaud and Mrs. Maya and all the crew for this amazing event. Thank you so much for everyone for coming. Sorry that I speak in English. I would like to speak Serbian, but I promise now with this beautiful project that's MEDIBELLA, I will try to learn some Serbian, so next time I can talk some words for you, okay? Well, today we are talking about genetics. And I have very good news. Genetics is not our life sentence. Genetics is something that we can change, we can modulate. We can do things to change the expression of our genes. And I'm going to show to you some information, some basic information about genetics. I agree that most of you know a lot of these things, but I'd like to display some things. All my presentations, I like to show this, okay? We are here. We have a lot of people here. 99.9% of us, we are the same. Exactly, we're the same. We have 46 chromosomes and the same genetic information, 99.9%. 0.1%, we are different. There's a difference of 0.1% only. And inside the 0.1%, there are more than 6 million variations. So what is a variation? Variation is something different from what is expected. So we are different, not only related to our color of our eyes, color of our hair, but we are different inside. The way our body reacts to the environment where we live, how our bodies react to the lifestyle we have, to the treatments we receive. So this is what makes us very unique. Inside of us, we have 37 trillion cells. At this moment, each one of us, 37 trillion cells. And believe me, we make every second more than 1 million cells per second. So 1 million, 2 million, 3 million cells. And we are like an industry. Our bodies are like industries. We have the capacity of producing, and like a big factory, there are also some mistakes happen. And our body has the ability to fix those mistakes, those errors that happens every time a new cell is produced. When we lose this capacity of repairing, of fixing these mistakes, diseases come. And not only disease, but aging also. So as we get older, our telomeres, and today I was telling in Aero News about that. The telomeres are, let me show the next slide for you. Okay, the telomeres are the edges of our chromosomes. And as we get older with the multiplication of the cells, these edges, they are reduced. And these edges contain information that can protect our body against the diseases. And also, how can we understand that? For example, if I make a photocopy, like in my age was a Xerox copy. We make a copy from a drawing, okay? And we make a copy after the copy in the machine. Press the button start, and again, a copy, a copy, a copy. After thousands of copies, we are going to see the image fading, disappearing, and this is what happens to our chromosomes with our telomeres. So as we get older, our ability to repair our cells, to repair our body, get diminished. That's why wrinkles come. That's why chronic diseases also come, cancer come, and this is the magic. How can we stop aging process? This is a basic drawing from our chromosome. We have the DNA, and DNA is not more than a rolled chromosome, okay? So when we open the chromosome, we have the DNA. So in the next slide, we can see changes of what is expected and what is changed. Okay, in this slide, I'm going to pass very quickly. I don't want to make this a little annoying for all of you. But we have on the right side a phenotype of a guy who is normal body. He has a good shape, okay? So we have here on the left side from the father, normal, and also normal in the mother side, okay? What happens if you have an alteration from both sides, something which is not normal, okay, from the father side and the mother side? That means that may affect your phenotype. That means this is an obese person, like I used to be, okay? I have 4 variations, I'm going to show you. I have 4 variations from one gene called FTO, which is responsible for weight gaining. It's the obesity gene, okay? Many of us we have. So how can we modulate that is the big magic. This is how we can deal with our genetic variations. Okay? Let's pass here. So as I mentioned to you, we produce more than 1 million cells per second. Different tissues from our body produce a different quantity of cells per second, even per day. So we can see that the brain and the heart, they do not produce so many cells. So those are organs that we need to take much more care. Why? Because the capacity of regenerate the heart, the brain, is not like the skin. The skin has a different production of new cells. In about 25 to 30 days, you have a completely new skin. Okay? It's the intestine, for example, the gut, in 4 days, we have a new layers in the skin of the intestine. So each organ is different. This is one of my favorite parts. Many from you saw this map already. This map was created by Dr. Yasko from US. And years ago was amazing. And when I saw this first time, I said, wow, this is so simple and so full of information. We call methylation or methylation cycle. What is the methylation? Each one of us, we have the ability to turn off our bad genes. We have good genes, and also we have bad genes. I'll give you an example. We have the genes that cause cancer. We call oncogenes. But also we have the genes that stop the cancer. We call the TSG, tumor suppressor genes. So it's like a chess game. One side, the oncogenes, other side, the tumor suppressor genes, and they need to fight. So the oncogenes, they should be turned off, because if they are on, our chance of developing a cancer is higher. So this map shows, I know it's a little bit complicated, shows the process of methylation. When we donate methyl group in chemistry, CH3, that are going to be put in the cytosine location in our DNA by an enzyme called SAM. Look, this is the way we see people now. So this is the metabolic map, and this is myself. This is myself. This is my metabolic map. So here, what I looked at, because I know my mutation, so this is something really unique. So no other company other than Precision has the metabolic map this way. So we found a way to check each part from your body. And what we can see in this map, I know it looks like complicated, but I tell you the truth, it's not complicated to analyze. This is what we see. Okay, look this. We have up left longevity, the right, up right longevity. We have on the left side dopamine cycle, the cycle of the production of the neurotransmitter dopamine, and on the side, the production of serotonin. We have the cortisol area. We have the folic acid conversion. We have the blood pressure. We have the thyroid. We have the Alzheimer risk, inflammation, which is very important. When we talk about aging and inflammation, they walk together. Okay, it is very important to have in mind. Methylation on the right side. Methylation is, as I said, the ability of turning off the bad genes. Detoxification. This is something interesting. Detox is something that from maybe 20 years ago, it started to be more popular. And this is true. In the beginning, I said, oh, I don't know, but it's true. Detoxification, the free radicals, the oxygen reactive species are very important to understand. And this is controlled by our genes, okay? We have the mitochondria. So many of you, sometimes we look at you in the mirror and say, look, I'm tired. What's this face? You know, I have my eye bags. What's happening to me? Why I feel tired in the morning when I wake up? It's mitochondrial dysfunction. And who controls that? Genes. Can we change that? Yes. Another thing, cholesterol. Why cholesterol is so important? Look, when we have a patient with cholesterol, most of the doctors, what do? They give statins. Okay, but statin works for people in a different way. Some people, they need statins because the statin is going to stop this gene that we can see right here to work, which is the HMGCR gene. But if you have other reasons for the high cholesterol, like the apolipoprotein B, or the LDL receptor, or the PCSK9, then the statin is not going to be so effective. There are other ways to do. But how can you know why the reason? What's the reason for your high cholesterol? Only genetics can tell you. And the same thing for diabetes. Exactly. For diabetes, it's the same thing. We can only know what's the reason behind the diabetes of a patient looking to your genes. Otherwise, say, oh, it's insulin resistance. Not always. Not always. Insulin resistance is around 40% of the patients. 60% are other reasons with a strong genetic background. Doesn't mean that you have a father diabetics or a mother diabetics that you're going to develop the diabetes. No, it's not 100% like that. But the genes can tell you information that you can prevent, or if you're already sick, what you can do to reduce the impact of diabetes and have a normal life. Okay, so now let's give a look inside the neurotransmitters. Let's go back. Okay, I like this image a lot because this is one of the most important genes, COMT. Here, who heard about this gene before? Anybody? No, okay. The COMT gene is the gene that controls the degradation of the dopamine. And what's the dopamine? Dopamine is a neurotransmitter related to motivation, to attention, to focus, to interest, to pleasure. So if this gene in your body is not working well, and what does it mean working well? There are three types of people, as you can see in the image: fast, slow, and intermediate. And if we divide the population, between you here, I know that 30% of you here are fast degradators, are COMT fast, 30% COMT slow, that you destroy very slowly, and 30% you are COMT intermediate. Do you know what you are? No, genetic can tell you. And this is very nice. Why? Because if you have anxiety, if you have depression, mood disorder, attention deficit hyperactive disorder, or only attention deficit disorder, problems on concentration, memory, could be related to this gene. Can we change it? Of course, but we need to understand first what's your variation. So this is one of the genes we need to understand what you have. Okay? So many people that come to do our test, they have no idea that they are having some aggression. Sometimes they have some strange behavior. And this is because of this variation called COMT. And people who has COMT fast, COMT fast, they have higher cortisol. And cortisol is the stress hormone. That means if you are COMT fast, you are red there, means that you degrade the dopamine very quickly. And you are going to gain weight, because cortisol also helps you to gain weight, to accumulate especially the visceral fat. So all is connected, and we can modulate, we can see things. So understanding your genes in the way that we display, and I'm so happy to be here in Serbia with MEDIBELLA to bring in this technology, to bring these innovations to you. You can really see many improvements. Like in children, for example, if you have a child said, oh, my son is very lazy, very lazy. So what's this laziness about? Does it have any gene behind of that? Yes. There is a gene called ANKK1. We have in this picture here. The ANKK1 is the procrastination gene. Are people who say, no, I'm not going to do this now. No, I have to do this. No, I'll do it later. I'll do it tomorrow. Procrastination gene. We can see in the genes. So before telling your son, oh, you are lazy, go to do that. No, maybe it's your genes are responsible. So we can change. Okay, how can we change? They're here in this panel. This is a panel. This is a report. Instruction of what to do for each situation. For each gene, you have a recipe. You have a way of changing what is happening. So it's so interesting and really works. And when I say that works, it's not based on Professor Roberto's experience. It's based on the literature. So we have a very strong literature background on every recommendation we do. We cannot just say, do that because it's good. No, we need a base, scientific base. And the scientific base is there. So in every report we provide comes the scientific bibliography, references of peer-reviewed publications. So this gives you the comfort of having the information, okay? Another gene which is very important that each one of us should know about it, I was talking to Dr. Leonard about this today, is the MTHFR. So this is more popular than COMT. I believe that many of you heard about this gene, MTHFR. If not, this is important to know, okay? Because this gene, this is right here, okay? You have two main variations. One variation that we call 677, and the second one that we call 1298. And what's that responsible for? Okay? This is responsible for the production of methylfolate from folic acid. So in many countries, when a woman is pregnant, the doctors, they prescribe folic acid, all right, to prevent the neurotube defects. In some countries, I was informed that they are not prescribing anymore folic acid, they prescribe methylfolate, okay? What methylfolate has in the name? Just say methyl. Methyl is CH3. Remember when I said in the beginning, CH3 cancels the bad gene, right? So if you have a problem in this gene, MTHFR, your ability to turn off the bad genes is reduced. It's reduced like this patient here, 677, which is me, it's myself, 677 red. That means that I convert only 25% of the folic acid into methylfolate. So I have a deficit of 75% of methylfolate. What means? The bad genes that I was supposed to be turned off in my body, turn it on. When I was 33 years old, now I'm 54. When I'm 33 years old, I found a cancer in my body. I had no idea why this cancer was turned on. Now I know I had 677. How could I prevent that? I should, if I knew it before, because I'm in genetic field the last 13 years only. If I knew that before, I would be supplementing myself with methylfolate and methylcobalamin. Methylcobalamin is vitamin B12. Knowing that, I will be methylating perfectly, I will be turning off these genes that cause the cancer, and things will be different in my life. So this happens to many people. Not only the 677, 1298 as well. And what other diseases that happen? Hypothyroidism. So many women with hypothyroidism, especially Hashimoto thyroiditis, they have mutation in the gene MTHFR. Not only the 677, can have a 1298 or both of them. Hypertension, people with hypertension, most of them also may have this variation. Lupus as well. Many cases due to MTHFR and so many other diseases. So the soonest we detect this variation, we can change our life. And one thing very important is that when you have MTHFR, your aging process is extremely accelerated. So when you see that you have this gene and you start to treat this gene, you can even stop your aging process or decelerate your aging process, okay? So there are many things we can do. This is a sample. I don't want to take too much from your time, but this is very interesting. This is about the skin aging, okay? And this is a personalized report about the skin aging. So what's interesting about that? Look, each person has a different skin, okay? We realize. But the information inside your body is what determines how older you are going to get. So sometimes I see patients like 20, 25 years old with the skin of a 50, 60 years old woman. Why? Because it's written in your genes. There is a variation responsible for a process called glycation. What is glycation? Glycation is like the caramelization, sorry for this word, a little bit strange, like a sugaring, like when you're cooking, like you put sugar, it's like caramelizing your cells. Why? Because this gene allows your collagen to be attacked by the sugar, carbohydrates in general. So some people, they eat the bread, rice, they eat even the sugar, they will be aging quicker than others because their body cannot deal with the sugar so well. They glycate so much, okay? And this can be reversed. This can be stopped, this process. I have a very bad glycation in my body. I take daily a supplement to stop this process. And I tell you the truth. If you want, I can send you some pictures of me like 10 or 15, 12 years ago when I started the supplementation, actually 10 years ago. You stop the collagen. Okay, I'm going to say, but I cannot prescribe, okay? Is the chromium picolinate. Chromium picolinate. Okay? Chromium picolinate stops the glycation process, but this is inside out. Okay? But it's very important as well to know what's the right procedure you have to do. Collagen stimulation, okay? Feelings. This is a super important, okay? Because you can recover what you already lost. And genetically, what's the good thing? Genetically, you can know, like here in this report, this sample I put here, what's the best procedure for each one of you according to your age. So what's this report calculate? This report calculates not only your genes, calculates your lifestyle, because there is an interview before. It was a questionnaire. There is your blood test, your image test, your picture. So everything's inside this report. It's produced combining lots of information. And then you know what's the right procedure. For this patient here, she's a female, 34 years old chronological, 32 years old biological. I used to say we should have 2 birthdays parties. Really true. One for our chronological age and one for our biological age. And I tell you, when I started in genetics, and especially in the epigenetics I started testing right in the COVID time, 2019, end of the 2019. And I found out I was 13 years older biologically. I said, my God, that means I'm dying, right? What I did, I started to reverse that. Today, I'm proud to say I'm 4 years younger. Can I be better? Of course I can be better, okay? But in my case, it takes time because I have very bad genes. That's why I'm a geneticist. I try to fix myself, I fix myself, then I can fix people. But I have patients with 76 years old, they have 48 years old of biological age. This is really incredible and happens. Like in the blue zones, for example, in Okinawa, I have a patient there, he's 102 years old, and his biological age is 82. So this is genetics. This is how we can see people. And what's the best procedure for one person is written in your genes. So how long the hyaluronic acid will stay in my body, how long the Botox will be working in my body. The genes tells you the story. The genes will determine this for you. So this is amazing because you do the right treatment according to your genetics, okay? So this is a real patient, okay? And what is also interesting, she has her apparent age, 32 years old, okay? Coincidentally, biologically. And at the time, okay, sorry, I need to hurry up, okay? So let's go, just show you other things. This is the personalized pathway about the liver. Fatty liver disease is a pandemic, okay? So years ago, nobody heard about non-alcoholic fatty liver disease. Today, countries like India, 38% of people, they have fatty liver disease. We can see in your genes if your chances are big or not, what you can do. Also, about the woman pathway, this is fantastic. This we can see if you have the peri and postmenopause, if you can develop cancer, if you have BRCA1, BRCA2 gene, and also your estrogens levels, your hormonal levels, what you have to do in the menopause. It's fantastic. You can see all the information here. But don't worry. For each report like this comes an understandable report. Okay? This is the cholesterol pathway. And then we have also system to analyze, but I don't have time to show you this now, but everything is integrated. It's very easy to analyze, to combine information. This is supporting material for the doctors. And that's all. Thank you so much, everyone.